Hello and welcome to Dinis Guarda YouTube podcast show. Once again, profiling the personalities, the tech leaders, and especially the passionate people that are leading and transforming our society, our tech, and our businesses. So I'm quite excited to make this session based in Munich, Germany, and as well within the context of Siemens AI with Purpose Summit 2024. So today I'm actually very excited to profile and interview one of the personalities that is actually building a lot of the infrastructure, how we deal with industrial AI, industrial grade AI, but especially someone that has a fantastic experience dealing with technology, with business, and as well keeping a bridge between all the different areas, between the way the evolution of artificial intelligence and how that is affecting society. And of course, we're dealing with one of the biggest multinationals and the technology and corporations in the world, Siemens. That is, of course, a company with over 177 years that has been actually one, I would say, beacon of hope in the context of the technology and corporations in Europe, but as well a beacon of longevity, which nowadays is something quite unique and I would say very special. So today I welcome to our series Boris Scharinger, that is a personality of Siemens, but as well a personality of technology worldwide. And as we speak, Boris is senior global personality in the organization, and his role right now is leading part of the technology in the role of director of IT and director of the different parts of the network of the CTO of Siemens worldwide. In terms of his background, we can go through a career that spans 2 decades and that comprehends been working in some of the biggest corporations worldwide, from Atos to Siemens, and as well with an academic and research background that combines business, technology, and corporation. So from his experience, especially at Siemens, he has held several roles through the last years, and has been as an IT infrastructure manager for logistics and assembly, and then became a global shared services IT portfolio and organization manager, and subsequently he has been appointed chief IT architect of Siemens IT solutions and services, a position that he held until January 2008 to March 2011. During this period, he's been working in a crucial role on implementing the IT infrastructure for the large company in over 40 countries. And his role right now is working in a much more senior position, where actually is leading and integrating a lot of the strategy of Siemens technology and artificial intelligence worldwide. So Boris, it's an honor to have you here. And I'm quite excited as well to talk with you and understand you have a fantastic energy and a passion for the things you're doing.
Yes, indeed. Great for being here. It's a pleasure to talk a bit about maybe also who I am, where I'm coming from, about the amazing universe of Siemens and our passion to make AI industrial grade, which is really a huge task in front of all of us.
So, Boris, you have a fantastic background that is quite corporate and very tech-driven, but you have as well an academic background and as well I think it's something that is unique in Germany compared to the rest of the world. But can you tell us a bit your background, your education, and how you end up actually in this fantastic career?
Well, I had the opportunity to be one of the first students who could study the combination of business administration and computer science. And that's where I did my master's in. But I do admit that one important impulse for my career came from a slightly different direction. I was, as a teenager, a big fan of a company called Acorn Computers from Cambridge, and they produced a wonderful home computer, very efficient, very beautifully built. And we liked it so much, we decided to set up a computer store and sell these wonderful pieces of technology to the public. But you bet what? It didn't sell. We went insolvent and it didn't turn out, and that company, Acorn, today doesn't exist anymore. their CPU branch did, by the way, and it's a small company today known under the name of ARM. But that's a different story. Why am I telling this? Because very early in my career, in my early 20s, I learned that a beautiful piece of technology doesn't sell by itself, right? And this is why in my studies, I developed a passion to understand what is marketing about, what is the 4 Ps of price and product and placement and all of that. How does this work? Because I really wanted to understand from my own frustration, why can't a beautiful piece of technology not just hit the market and be very successful? So that's where I put my emphasis in my education. And later during my career, I had so many opportunities also to leverage that combination of skills. That's why I am who I am, so to say.
Oh, that's very inspiring. So how did you combine that experience and as well part of that experimentation that didn't work very well with both your studies and academic career, and how do you brought that to a big corporation? Normally, the big corporation we see very stable, not a lot of innovation, not a lot of different things. And I know that Siemens is quite different, but on your history, on your education, how did you put that together?
It's quite the opposite in a certain sense. Siemens has always been a company of engineers driven by passion, right? So the technology innovation kinds of comes natural. We have so many engineers and they like to invent, and many of them have their sandboxes and build stuff. It's all amazing. But to coach them and to give them help and to make them understand what does it take to make an innovation successful on the market, right? This is the aspect of innovation management that you need on top of it. And having that background, of course, I'm occasionally helpful in helping engineers to mature their product, mature their ideas in a way that they really resonate, including resonate commercially on the market.
So from the academic background, how did you put that academic background marching? And I know that Germany is quite unique because normally the business in Germany is associated with academic research and academic practice. How do you put these two things together?
If you go through the educational system in Germany, specifically academia and the universities, abstraction, right, conceptual thinking is what you really learn. And that helps a lot. When I first started my professional career, I spent then 6 years in IT consulting, helping large corporations to transform also the way how they do IT. That's also how I met Siemens as my first customer on that consulting company. And when you do consulting, you really learn about the human factor, right? About change management, transformation, resistance, project management that helps to get across those hurdles of resistance when you induce change with the help of technology and IT into organizations. And I did this 6 years. And during these 6 years, I had the pleasure to work for Siemens as my customer. And at a certain point in time, Siemens embraced me tight enough. So I made the choice to, in 2004, embrace Siemens as my employer and started from there. And it was exactly continuing on that path. I worked in the internal IT and service management of internal IT because Siemens at that point in time decided that we cannot allow super heterogeneous IT being provided and being operated everywhere by individual teams, but to form a global set of services, of IT services, standardized KPIs, and so on. And that is not a technology change. This is a change how people work. This is a change of people need to see a future in a centralized setup where previously they could work decentrally and had their own playgrounds, if you will. So I was for several years part of this huge transformation of the internal IT of Siemens. Amazing and also a very global task to do.
Your present role is a senior innovation manager and technology strategist.
Yeah.
So you deal with two of the most complex parts of the world because in one end, innovation nowadays is a moving target and strategy is as well very difficult, especially with everything happening in technology and especially with artificial intelligence coming and disrupting everything that was already disrupted. So you mentioned the 4 Ps and you mentioned your focus on passion and innovation. So how do you keep this pace of innovation and strategy with all the disruption coming from outside and especially for all the disruption that comes from all the fourth industrial revolution areas and from artificial intelligence in particular?
The good news for me is I didn't have to start at zero, right? First of all, Siemens, and particularly Siemens Digital Industries, is already a market leader in Industry 4.0 concepts. I didn't have to bring that to Siemens Digital Industries. No, that's what my colleagues have built up for so many years. When I started to look into the amazing area of AI in 2018, when I joined Digital Industries, I did a gap analysis and said, this technology is coming from this side. This is happening. There are certain trends. There are certain ingredients that you need to take care of, such as, for example, talent, right? And I did the analysis of, what's the starting base? And I found out amazing things. One of the amazing things was we have 1,440 data scientists spread into the business units all over the place. So technology access, having the talent that knows how to tackle AI challenges, the access to talent, the access to technology and technology expertise, that was already there, right? What wasn't there was the perception in the market. Hey, Siemens is actually a leading provider of AI technology for industrial use cases. And then I started to rethink, how do we position ourselves and how did we position ourselves in the terms of how we speak about AI, and how should we approach the markets? How should we approach the ecosystem differently to make sure that it's fairly easy to understand what is the mission of Siemens in the area of AI?
Yeah, this is very impressive, especially bear in mind the scale of Siemens and the scale of like you mentioned, the different countries, the different personalities, the governments you work with, and that's where we're talking about industrial grade innovation and technology and solutions. So one of the questions I have here is Siemens, although as this scale of employees of dimension and as well being one of the biggest corporations in the world, it has kept a very strong sense of trends and innovation. So you mentioned Industry 4.0, that actually is a concept that actually came from research here in Germany.
Yes.
And as well, you've been actually working, I'm talking all the Siemens, from digital twins technology to metaverse enterprise, and increasing right now the concepts of industrial AI. So before we go to industrial AI, I would like to just this major parts, how you assemble all of this together between the corporate part of the work, of mobility, of software for industry, and all these different parts. Because, of course, one thing is talking this academic, the other thing is putting in practice and projects that are billions of dollars projects that touch governments, thousands, and sometimes millions of people.
That's a good question, and it's maybe not a question that I can even answer in a homogeneous way, because Siemens is a universe. Siemens is very heterogeneous too. But what our board has very early done is we have kind of received a little bit of a leitmotif, right? Siemens is having great software, but we are not a software pure player. Instead, we are the ones who combine the virtual and the real world, right? Because ultimately in the industry, when you produce something that is tangible, it's machines that produce that piece. In the end, you need to master physics. And having Siemens as an engineering culture with so much knowledge and skill about physics, about drives, about a precision, wonderful, just amazing, just awesome. And yes, we combine this with digital. So we have this leitmotif, and the leitmotif is something that really is part of the culture now. And whenever we think now physics and physical items, we immediately think, what's the digital representation of it? Do we have the tools at hand to simulate this thing, simulate the machine, simulate attributes of product features? So all of that is the roof of bringing the virtual and real world together. And this helps. This is a marked road on which everyone in Siemens can kind of drive to arrive at any target that you have set for yourself.
Yeah, that's very inspiring. And I would say that is probably one of the most important things that all of us have to bring for our lives and for our business and ecosystem, especially for society. So in terms of part of your role, of course, you've been contributed and as well part of your career in a lot of different research papers and publications. And I know that you and Siemens have been pushing the boundaries and the definition about what it means industrial AI and the role that industrial AI is increasing in our society, especially in governmental level, and of course all the areas of transportation, all the areas of technology related with softwares that are used by all our infrastructure. And I think this is one of the areas that is unique in the world, because there's very few players that have somehow this concept. And of course, we are all talking about generative AI, but we're not talking about the importance of legacy systems mixed with more advanced systems. So first of all, if you could actually highlight how do you see industrial AI, and as well some of the areas that make industrial AI so powerful, because I know that is a concept that not a lot of people is talking about, but it's a concept that is more important than ever. And if you look at it, probably you see a lot of important things to, firstly, create a more, I would say, utopian, or at least more innovative responsibility towards technology that is less disruptive and probably less, I would say, there's a sense of catastrophe and a sense of doom in the scenario of AI. So I would like to hear your opinion about this.
Let's start with the motivation. The motivation for all of us must be to change this world for a better. We all are impacted by sustainability challenges. We all are impacted by the climate change. This is real, and this fundamentally impacts the way how industry must work in the future. We must be able in 10, 15 years from today to produce what mankind needs, but with significantly less resources than we are doing it today. And that's a fundamental transformation that we need to see happening in industry, right? For the sake of the future of mankind, actually. And we need to use any weapon that we can get, any tool that we can get that helps us transforming industry. And AI, for sure, is a very strong weapon in that. Let me give you an example. 80% of the CO2 footprint of a product are actually determined during the design time when it's designed, right? You can only marginally change and improve the CO2 footprint later on after the design has been made. Now, let's look into the space of design space exploration, where in virtual reality, supported by simulation, you generate thousands of product variants in the digital space, in the metaverse, before you produce them. You use simulation to assess all of these design variants, and that's why you need to be strong on the simulation side and also leverage AI a lot to speed up simulation. Because if you have 1,000, 5,000, 10,000 variants of a product design, it's going to take you a long time to compute and to simulate all those variants to come to a great decision. What is my best design? So AI is really needed to speed up simulation processes. And then you can add different perspectives. What's the energy that is consumed within the parts that I source to build a product? What's the energy that is consumed as a part of my own production process, my own shop floor? What's the energy that is consumed when I later on recycle the product? And if I have 5,000, 10,000 variants of such a product, can I simulate the production? Can I simulate the sourcing variants? Can I simulate this recycling in a way that it comes up with, here are your 5 best variants of this product from an energy efficiency perspective, for example. So AI plays a crucial role to help simulation be a lot faster so we can design better products, which translates into consuming a lot less resources than that they are consuming today. So having said that, it's a strong motivation for us to work with every tool that we can get on the digital transformation of industry, and AI is a strong tool. When I look into AI today, and AI is actually designed and shaped a lot from the consumer space, from the search engines, from the social media platforms of this world. And in these environments, you can allow for a certain error rate. Yeah, in many cases, 90% is good enough. However, in an industrial production process, I cannot have a robot that works in 90% of cases. I need to have robotic solution, gripping something, for example, and putting it somewhere on a conveyor belt, that really must work for 24/7, must work 99.9%, and, for example, must be able to process 1,000 picks per hour. Now, these industrial requirements, robust reliability, this is what's essential for industrial AI. Now, industrial AI, in a sense, is the application field. It's the application of AI in industrial use cases. Our quality ambition, and that's why we have coined the term, our quality ambition is, let's make AI industrial grade together. So AI meets the tough requirements that you have in industrial processes.
Well, that's a very great description of the challenge that comes, and as well the possibilities when it comes to especially all the physical, digital, but as well how this highlights the impact on sustainability and the future of the planet. Like you said, I think for everyone listening to us, wherever you are in the world, you see, I think, all the effects or the consequences of climate change. And this is going to be bigger. So whatever we can do in these areas, it's very important. So one of the things I would like to touch, and you touch all these different things, but I'd like, and you're great on definitions, is, okay, at the moment as we speak, there's the definition of physical and digital. Then there's the concept of digital twin, the concept of metaverse enterprise, and of course, this is all aligned with AI. I know that at the moment there's a lot of myths around the especially metaverse, and that most of the people don't still know what it is, a digital twin properly. But Siemens probably is, I think, leading this in the world, and both in terms of documentation, process research, but as well making it in practice. So could you describe these concepts and actually go with probably one or two examples of what you've been doing, both in big factories, or for instance, the case of that you guys did an entire island, for instance, Azores in the Atlantic Ocean. So whatever case study that you like, but going through the definitions of these topics, which I think are very important for everyone listening to us.
It's a great question. And the metaverse is a concept that, in a certain sense, has been a bit negatively impacted by or associated, right, with the metaverse on the consumer side of life. And this is not what we are talking about. No. Simulation is, first of all, important. And I explained already a bit earlier why. Right? We would like to be able to explore the best possible designs, the best ways of how to produce by simulation first, before we then push the button and real resources of this real planet are consumed. So it is optimizing designs, it is optimizing processes, because you do it in simulation first. Now, you can start simulation on a component level. Let's take an electric drive, right? There's a couple of cables and whatnot, and we can meter it, we can have sensors, we can measure vibrations, and we can see the power consumption, the torque of that drive, and we can take that drive and create a digital twin of that drive, which matches and mirrors the behavior of the physical one. Great to have a digital twin of an electric drive. But the electric drive is always built into a drivetrain. There's a pump being powered by that drive, right? There's a CNC machine maybe powered by 3 or 4 of these drives. So now we are leaving the component level. We are immediately looking at the system level. There's a system CNC machine, or there's a system powertrain, right? But then we don't stop there. It's a machine, but that machine is embedded in a production line. Hey, okay. Let's not stop simulating the machine. We really want to design the production line and the pacing of the production line in the most efficient way. So now we are on a line level, and the line is just one line in a factory. So, oops, now we are on a plant level and say, oh, there are several lines and they interact with each other, and they interact with each other also logistically. I would like to simulate that, because if I simulate it, I can optimize it, ultimately helping us to consume less resources. And then someone says, yeah, wait a minute, it's just one factory, but we have 20, and this factory produces this, and this factory produces this. And there are lorries and trains and freight trains going between, and there's interlogistic, right? And then there's this third factory that assembles all of that. So let's put the logistics network of several factories on top of that simulation. Because if we can simulate that, we can also make the production better and maybe have less freight trains running and going between the factories if we optimize it. Now, you need to have an aggregation platform for all of these digital twins, right? You need to have one platform where you can say, I have an interchangeable format. I know how to plug digital twins together because I get a digital twin from a component here, get a digital twin from a component there. I model it up to the machine level, go further on the line level. And what we really mean by the industrial metaverse is this aggregation level of digital twins reflecting the behavior of physical elements being fed and calibrated regularly with real-time data from the shop floor. So we know that the simulation, the digital twin simulations, they are in sync with what's happening at the shop floor. Ultimately, we use that as a platform to simulate as much as possible so we can optimize as much as possible, therefore reduce our resource footprint and consumption.
Well, a masterclass. Well done. I think it's really, for people listening to us, I think repeat it and learn it, because I think it's one part that is very badly explained in general in the internet and research. And there's a lot of myths, especially when it comes to metaverse. But I think the way you put it, Boris, is amazing. But as well, it highlights as well the possibilities we have with this. So picking on the areas of the physical, digital, and of course the digital twin and the metaverse enterprise, and then we're coming back to industrial AI. Mm-hmm. So all of these things are, of course, working together. It's not like AI appears like magic. And it comes to, there's a lot of innovation and relationships, especially right now with the immersion of the powers of generative AI, which comes from big large language models, LLMs. And at the moment, we are in a particular moment that is, of course, very exciting and in some ways, of course, scary, when we go into a point where some of the machine infrastructure and these LLMs that are starting to put together are starting to create what we might define or question artificial general intelligence, AGI. So bear in mind that you're dealing with a lot of complexity, with a lot of governments, with a lot of infrastructure. For instance, if you are in Europe and you go to a city like Budapest, you see on the streets of the town, Siemens. So it's there on the floor. So that shows how big we're talking here and an impact in society. So, and at the same time, you are agile enough to, you just recently released the industrial copilot. So, but I think the question is, how do you put this assembling together? And how you precisely know where to go to the radical innovation and disruption, especially in generative AI, and at the same time use this as a great tool to improve all the systems, legacies, governments, and of course all the innovation, but as well making sure that there's a path towards the future that is sustainable, like you said, and as well, I would say, with a positive, inspiring level, which I think we need more than ever.
Yes, indeed. So what we, for example, do is, right, if you look at innovation generally and so on, we work with startups. We invite startups to show what they can. We have factories. We can leverage the fact that we have factories and have startups trying and testing out their solutions. So we help them maturing it. That's, for example, one way of getting signals from the market. Where's technology going? A little bit of outside-in innovation, as we call it, right? That's important. The other thing is, as I said, we have so many engineers and they love to invent stuff. So here the challenge is really, how do we go from an idea and from a great proof of concept into something that is hardened enough, that is matured enough to launch it as a product? And what we also see is we have this internal platform in Siemens, right? Amazing platform. AI Attack, it is called. Hundreds of people can use a secured platform for leveraging GPTs for their work. And we see hundreds and hundreds and hundreds of people doing trainings and, webinars and so on, skilling themselves up enough so they can do prompting and they do experiments and try to improve the particular process on which they are working, whether that's accounting or HR, you name it. However, we can see with generative AI that despite the fact that there are hundreds and thousands of people pushing in, and working on their idea. So it's really a democratizing of AI, that the output, the number of use cases that you see in production, is very limited. Why is this? Because everyone loves to try out. But when do you know that good is good enough? Is 80% of a hallucinating large language model good enough for my use case? And how do I do this difficult thing? It was so easy for me to go from 0 to 80. But how do I get from 80 to 100? And it actually turns out, and this is why we have to bring some realism into the generative AI hype. Yeah, it is particularly difficult with large language models and with large models in general to mature them in a way, to mature the solutions in a way that you can go from the 80 to, say, at least the 95 to 96%. New test concepts have to be invented. What do you use for testing? How does a unit test look like for generative AI? How does a system test look like? And we have a cultural challenge here, right? Because data scientists are free-flying butterflies sometimes, right? They love the challenge and they fly from challenge to challenge. And if then someone comes, like Big Bad Boris, and says, no, we need to apply a stringent software engineering process on top of your explorative data science work, we really need to establish the form of art of software engineering for AI solutions, right? Then we have a little bit of a culture clash. But again, Siemens is such a wonderful universe because we have all of these skills and we can bring these people together, which is just one small part of our own journey as Siemens to mature AI to become industrial grade. And I'm very proud to say that the way how we shape these industrial co-pilots, we started those projects 2 years ago, and we had so many clarifications, so many obstacles to get out of our way. Legal clarifications, export control clarifications, technical clarifications. How do you deal with the fact that the providers of generative AI are changing their model every 2 weeks? But you are supposed to deliver an output to the customer that if you create and generate PLC code with the help of generative AI, that should be stable. That should not change. That should have a pretty predictable quality. And how do you establish these types of concepts? And if you mature something to become a product, you need to go there. You can't stop at the 80%. But we are getting there, and that's also because of the very strong problem-solving engineering culture that Siemens is part of.
Yeah, you make it sound simple, but it's really very impressive, especially all the complexity for people listening to us. Just working with regulators, working with governments can take, mostly you don't do anything for less than 6 to 12 months. And I think, of course, all of us take by granted all the security that we have, especially if you are in Europe, but even around the world, because if you look, for instance, at case studies during COVID, the world economy didn't stop. And most of the people could not get out of the house. So there's a lot of things that happen because of this engineering culture, and as well positive, focus-driven, solution-driven work. And that is very impressive work. So one of the things that I want to touch is, so at the moment, there's a lot of challenges when it comes to, I think, the day-to-day use of AI. And you touch, of course, generative language and the hallucinations around 20%. And of course, we have 2 or 3 companies that are concentrating enough power that can be scary enough, and as well the velocity. But I love some of the comments you made around this quote that is not completely yours, but you made it as well yours. That is, I will quote, and this was your word space probably in different things that we were elaborating. People will not be replaced by AI, but by people that use AI efficiently. Mm-hmm. So I think this is a cornerstone for everything that is happening with artificial intelligence. But as well, I think it's important to elaborate and to take this down to earth. And I think you touched that on the industrial AI concept and all the different areas. But for everyone listening to us, and I think unless you are living some twilight zone, you have concerns about AI, how this is taking jobs, creating a lot of disruption, family, and just the tip of the iceberg from efficiency of security and so forth. So bear in mind the complexity of the tasks that you are managing and as well all the different parts. And from your experience, can you elaborate on this?
It's important to understand that generative AI is something that is new in a way that it tackles and addresses high skill, high labor cost value pools. For example, if I have a lawyer and the lawyer is writing text, right, contractual contract drafts, then generative AI can really support that lawyer, something that AI didn't used to be. AI used to help really when it was simple, repetitive tasks. And now we go into complex, repetitive tasks. And that also means high cost competitive tasks. So that's new and that's interesting. And it's also it's not just the lawyer. It's also someone who designs logos, right? Or someone who writes software code. This is high cost labor because you need skills. You need to be skilled and you still need to be skilled. But a solid portion of repetitive work that you used to do can now be replaced or supported at least by generative AI. And the human can focus on, hey, I double check it, right? I have now 10 different logo designs generated. I'm going to pick for good reasons. And I know this conceptually why I can now pick and suggest the best logos to my customer. So these are examples where I say generative AI will find its way into many daily places. And we need to make sure that everyone understands how that works and gets upskilled to leverage generative AI for the respective area of responsibility and task. Two more thoughts on this. We really need to transform industry to become a lot more resource efficient. And for this huge transformation of industry in the next 10 to 15 years, we need anyways everyone that we can get to help there, right? That's one aspect of it. And the other aspect is a concrete example that I would like to share with you. We have this wonderful factory in Nuremberg where our Siematic products are produced, right? It's a high-pace factory producing so many Siematic controls a month. It's incredible. Now, this factory is in place since around 20 years with 800 employees. And if I remember it correctly, it was 20,000 square meters of factory shop floor. Now, in these 19 years, the number of employees that we have there didn't change. Still 800 today. We started with 800. The floor space didn't change. It was 20,000 square meters. Now it's still 20,000 square meters. But the output has been improved by a factor of 19. Let that sink in. And this output hasn't been improved just because it happened. The employees in Nuremberg driving digital initiatives, learning, upskilling themselves, experimenting, testing, improving, automating further, automating themselves away. If you are one person in Nuremberg, you automate yourself away. You are the one that has the next job safe for sure. Don't worry. And if it's not in Nuremberg, you will be offered the opportunity to become a project manager that rolls out the same thing in the international factory network of Siemens across the 70 factories we have worldwide, right? These are the opportunities. And this is a brilliant example of how we can manage and how can we can involve the humans. And then it's absolutely not the case that someone needs to be afraid of losing the jobs because of AI.
Well, thank you so much for that. I think it's, first of all, it's very reassuring, that positivity, but as well the importance of bringing this. I think the narrative is lacking in all the narrative around generative AI, innovation, and so forth. So fantastic. And I think for people listening to us, please rethink your words, rethink as well your tasks, because I always want this channel to be about education and about practicalities. So one of the questions when we look at big corporations and any actually organization in the world is how do you address the ethical and compliance concerns that arise from artificial intelligence on the use, the implementation. And of course, we touch about bias, security, transparency, and accountability. And of course, we talk about already, of course, about hallucinations and technology challenges. But let's talk especially on these areas, because I think, bear in mind your experience, and I think Siemens has a network of partners and corporations around the world and employees. We're talking about, probably if you put all together, the employees of Siemens, you have one of the biggest cities in Europe. So tell us a bit about these areas and how you go straight forward to the point, and eventually some case studies that I want to bring to the table.
Let me first start with an important foundation that Siemens has set up and invited so many industrial partners to join, which is the Charter of Trust. The Charter of Trust is an organization that really was first based on the understanding that cybersecurity is today such a huge challenge that not any company can master that challenge by themselves, right? We have asymmetrical threats on this planet, so a company cannot fight back on its own. And cybersecurity needs to be something that is, governance need to be made aware of, we need legislation to fight against it and so on and so forth. So Siemens said, we need to create a foundation that really takes care of things and shapes the future of where cybersecurity for society and cybersecurity for industry must go. Now, having talked a lot about cybersecurity, the Charter of Trust has recently extended their work into the area of trustworthy AI. So that's another invitation of companies working together, making sure we teach and educate politicians in what type of regulation we need, in what places, lobbying for by becoming more international on AI legislation and not just have a very strong European focus. So Charter of Trust has been extended to trustworthy AI, one side. On the other side, we have a consortia of different companies who worked on what we call the AI Trust Label, which is really an assessment methodology, right? How would an assessment look like to come to a conclusion that my AI fulfills many criteria of explainability, of privacy, of trustworthiness, of avoiding biases? What questions would you use in an audit to come up with a conclusion that, hey, my AI-based product is mature enough to fulfill many of these requirements in a sufficient way? So we have worked on a version 1 for the AI Trust Label with partners like Bosch, for example. And we continue now to work on a version 2 for the AI Trust Label as a self-assessment methodology. By the way, Applied AI is an important community here in Germany around Munich that is helping us to drive that. So we are working on the next version of it. And the next version will also incorporate a couple of more of the requirements that comes actually from legislation from the EU AI Act. So that's another way how we kind of drive this in ecosystems and the partnership so we mature. And then last but not least, the mission, hey, AI must become industrial grade. It's not yet. My slightly simplifying example is always, if AI would be robust and reliable, we all would be driven by autonomous cars, right? I don't know about you. I have not been driving in an autonomous car to this place this morning. So, and the conclusion is, if AI cannot run a car, how am I then supposed to run my factory on it? Maybe a refinery, right? You can try, but I don't want to live in the neighborhood of that refinery, if I'll be honest. So there's a long way to go, specifically AI and safety. And industrial grade AI means, hey, that's our quality promise from a Siemens perspective, but it's also our shout into the ecosystem. Let's make AI industrial grade together, because that's a team sport. Analogy to the autonomous car. The autonomous car cannot be built by a car maker. The autonomous car is something that requires that insurance companies buy in, politicians change the law, right? The certification bodies understand how in future they, what they need to do to certify a car that is autonomous. And the car builders need to, wrap up their technology and improve their technology in a way that it fulfills the promises. And with industrial AI, it's the same thing. We need to solve several challenges altogether to finally make it a lot more ubiquitous than it is today. And Siemens works in many areas on that topic. Last but not least, hosting the AI with Purpose Summit as a conference each year, now for the third consecutive time, that brings together practitioners from industry to join us in that mission.
Oh, amazing. And the way you put it is important. And I think especially for people listening to us, the focus on looking at the reality of the facts, not just on the hype. And there's a lot of, I think especially is one of the things that Germany has and Europe, that there's a sense of responsibility. I know that at the moment the publicity probably is not as good as all the innovation coming from the tech big players. But the fact thanks to these areas that you just mentioned, Boris, we have a security around a lot of this technology we're using, and as well a lot of innovation that is not sometimes so probably on the news as it should be. And I think that is one of the areas that we're going to be highlighting more on this series. So, Boris, and I know that we have limited time, so I'm going for probably the last one or two questions. Let's see the time. But so we spoke about AI, digital twins, metaverse enterprise, but your expertise and research, and as well, of course, the work of Siemens incorporates a lot of emergent technologies such as quantum computing and a lot of data economy related innovation. So can you share some of the highlights or some of the bases of this research and how you see all of these areas that we speak and we are touching, putting all together in the society that we're building? And like you said, especially when it comes to sustainability and building a present and a future that we all can especially leave a legacy for our children, but as well to be proud, because I think we don't live in a society that is completely dystopian.
Yeah, exactly. So quantum computing is another way to look at how do I solve huge optimization problems that I were not able to solve in the past simply because of the computational power that I would need, right? The idea of data sharing for a purpose, right? How can several companies look at one use case and share their data in a use case specific way so superior AI can be built upon that data pool? Or alternatively, using other means of creating trust like federated learning, right? But multilateral projects, co-creation, co-innovation for the purpose to become better. That's the common denominator, right? It's optimizing things, improving things, sometimes incremental, sometimes in a disruptive way. And that's why what I am living for, and that's why I'm trying to form that ecosystem, including a lot of startup work to make sure that we meet each other, learn from each other, and share our knowledge on the way to that mission, making things better in a sense.
Yeah, and that is the key element. So last one. So mostly for people listening to us, not everyone knows the amazing work that Siemens is doing and all the things we discussed during the path of this interview. So give us some advice, some as well document some of the research that people can find, some of your research, some of your teams, and especially our people listening to us. We touch about using AI to improve your job, to improve your different parts, and actually to upgrade your job. But as well, some case studies and some of this research that is shared, because I know that you publish a lot of research that actually I think everyone will want to be aware and learn from it.
Well, we have a website on industrial AI, by the way, and what we try to do in the past is we try to collect all sorts of different knowledge assets. We make knowledge assets available on our website, not necessarily knowledge assets that are only from Siemens and Siemens press releases. Who wants to read them, right? No, like white papers, research papers, and so on and so forth. That's one important element. But the most important element is join us on the conferences, join us on the trade fairs, join the discussions, because out of the discussions, we inspire people and get inspiration from people to move forward. We do a lot of research, and a lot of that research can be found on research paper platforms. Yeah, that's easy to Google. But it's the interaction between companies, it's the interaction between our partners and customers and us down to a personal level that really makes certain co-creation ideas become real. And ultimately, that's what it is about.
Well, I want to thank you, first of all, for this inspiring and very to the point. A lot of concepts, a lot of things we discussed here. I think just listen to it again. There's even me, I learned, I think, a lot of concepts and the way you put it in a simple, directed to the point. So I'm sure it will be not the first time we have Boris here, but Boris, thank you so much. Congratulations to your work and as well to the amazing innovation coming from Siemens and for this event as well. And I hope that you guys enjoy as much as I did. And I just want to keep sharing, learn, act, and please make sure that these tools are for your own use. Thank you so much.
Thanks for having me.
My pleasure.